Hello everyone, welcome back to Problematical, my YouTube channel. Today we'll continue our discussion of polynomials. Today we'll discuss exercise 2.3 of Maths 10 Standard ncert. So let's start. The first question is, divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. This is a simple division method. That means you have to divide the two given polynomials. The first polynomial is p of x, which is your dividend. G of x is your divisor. Let's write it in its proper form. X cube minus 3x square plus 5x minus 3. We know that we write p of x over here, which is your dividend, g of x over here, divisor. You divide it and get your q of x, which is quotient over here, and finally end up with a remainder, which is r of x. So, following this pattern, we will divide it. G of x is written over here. Proper attention has to be paid that the terms should be in the decreasing order of their powers. First term, x cube power 3. Second term, x square power 2. Third term, x to the power 1 power 1. Fourth term, constant. And same for g of x. X square term comes first and then the constant. Dividing this, x square has to be divided with the first quantity, which means your rougher could look something like this. X cube divided by x square. You'll divide the first term with the first term and you'll end up with x. That means if you multiply this x square with this x, you will end up with x cube. You have to write the term that you're multiplying your divisor with to get the dividend. You'll only concentrate on one term at a time. Now this x has to be multiplied by the complete divisor. Whatever term you get over here, you have to multiply it by the complete divisor. X into x square, you'll get x cube minus 2 into x minus 2x minus 2x. Observe, x cube term is written under x cube and minus 2x is written under x term. Now, since this first term has same sign, you'll subtract them. The subtraction process is simple. All you have to do is invert the signs of your newly placed terms. So x cube's positive sign got converted into negative. 3x cube minus 3x cube got cancelled. Minus 2x is a negative term. This negative term converted into positive. So 5x plus 2x becomes 7x. The rest of the terms have to be copied down as it is in again the decrementing order of their powers. Again, you'll consider the first term over here, x square and minus 3x square. You'll divide minus 3x square with x square, just the first term. We'll end up with the term minus 3. This minus 3 is to be written here. Now, you'll multiply minus 3 with the complete divisor, which is x square minus 2. We'll end up with minus 3x square minus 3 into minus 2 plus 6. This is to be written here. X square term minus 3x square is to be written under minus 3x square. 6 is a constant written under constant. Again, these two terms have the same sign, so you'll subtract them to cancel them out. The sign of the second term will change. Minus becomes plus and plus becomes minus. These two terms get cancelled and rest of the terms are copied down. 7x as it is, minus 3 minus 6 leads you to minus 9. Now, if you divide this, you have first term as 7x and here you have x square. Observe that the power of the numerator is smaller than the power of the denominator, which means no further division is possible. By this observation, we end up with the conclusion that x minus 2 is your quotient and 7x minus 9 is your remainder. These are your required values. You were asked to calculate the quotient and remainder. So quotient q of x is equals to x minus 3, this value, and r of x remainder is equals to 7x minus 9. You have to follow the same procedure for the next two questions. Let's try those. In the second question, p of x given is x to the power 4 minus 3x square plus 4x plus 5, and g of x given is x square plus 1 minus x. If you observe, this g of x is not in the proper decrementing order. So first you will arrange it. X square term comes first, minus x is second, and constant is third. The minus sign belongs to this term, x. So it will go along with its term. Dividing it in the form that we did in the earlier class, in the earlier example. Your p of x is written inside, which is x to the power 4 minus 3x square plus 4x plus 5. Observe that there is a term missing. So what you can do is you can leave a gap, leave some space for it. Or second option is you can write it as 0x cube. This is the term, cube term is missing. So you can write 0x cube over here, because you might get a cube term and then there will not be any place to place it. So placing g of x, you have x square minus x plus 1. Now, again, the same procedure. First term is to be divided by first term. So x to the power 4 divided by x square, we'll get x square. This x square is to be written over here. And then this x square is to be multiplied by the whole g of x. X square into g of x is x to the power 4 minus x into x square is minus x cube. Observe that I'm writing proper terms beneath the same terms. So like terms have to be kept in the same vertical sense. Plus 1 multiplied by x square is plus x square. Now you'll subtract them. Subtracting the signs of the second terms will be inverted. Plus becomes minus, minus becomes plus, and again plus becomes minus. These two terms will get cancelled. Plus x4, x to the power 4, and minus x to the power 4. Here you'll get x cube. Here minus 4x square plus 4x plus 5. Second step, repetition. First term divided by first term. X cube upon x square. This is x. So plus x plus x sorry about that, plus x. We'll multiply x with this particular term. We'll get x cube minus x square plus x. Subtracting, the signs get inverted. These two terms get cancelled. You get minus 3x square minus 4x square plus x square is minus 3x square plus 4x minus x is plus 3x plus 5. Again, the same procedure. Minus 3x square, the first term divided by the first term, which is x square. Now, here observe the two powers are same. The moment this step occurs, it should indicate that it is the last time you're using this procedure. That means beyond this, you'll directly get the remainder. So you'll end up with minus 3, minus 3. Minus 3 is to be multiplied by the whole thing. So minus 3x square, minus 3 into minus x plus 3x, minus 3 into plus 1 is minus 3. You'll change the signs, plus, minus, plus, minus 3x square plus 3x square. Inverted signs cancelled. Plus 3x minus 3x cancelled. Plus 5 plus 3. Addition is 8. When the signs are changed, the earlier signs are to be discarded. They are not to be considered. Only the new signs are to be considered. So your quotient is this, and this is your remainder. Q of x is equals to x squared plus x minus 3, and R of x is equals to 8. Next question. This is the third question. Again, P of x is given, G of x is given. Let's arrange them in the decreasing order. P of x may, it is in decreasing order, but certain terms are missing. So you can write them as 0 into that particular term. Writing the missing terms in your dividend always helps you out. This g of x can be written as minus x square plus 2. Minus belongs to x square, so it will go along with x square, and the sign of 2 is plus, hence plus 2. Let's try and divide this. So x to the power 4 plus 0x cube plus 0x square minus 5x plus 6 minus x square plus 2. First step is dividing the first term with the first term. Do not worry too much about the signs, just pay proper attention to it, don't miss any signs, and carry them forward as required. So x to the power 4 divided by minus x square, 2x got cancelled, and you're left with 2x. That means x into x. This is minus x square. I will multiply this minus x square with the whole thing, both the terms. So minus minus gets plus, x to the power 4 minus x square plus 2, which is minus 2x square. Subtracting, the second signs get changed, plus got changed into minus, minus into plus. X to the power 4 minus x to the power 4 cancelled. 0x cube plus 0x square plus 2x square, which means plus 2x square minus 5x plus 6. If your first term has 0, you need not consider it. That means this is not to be considered. You can directly consider 2x square. That means now you'll divide 2x square with your first term, which is minus x square. Again, the powers are same. So minus 2, and beyond this, you will directly get the remainder. Minus 2 over here. This minus 2 is to be multiplied by the whole g of x, which means minus 2 into minus x square, you get plus 2x square. Minus 2 into plus 2, you get minus 4. Subtracting, the signs got inverted. This got cancelled. Minus 5x as it is, plus 6 plus 4 is plus 10. Now, this is your remainder. Here in this step, you got your remainder and your quotient. So g of x is equals to minus x square minus 2, and r of x is equals to minus 5x plus 10. Hope that this was cleared. Let's continue with the second question. Now the second question states, here you have to check whether the first polynomial is a factor of second polynomial by dividing the second polynomial by the first polynomial. The method that we earlier followed is the actual division method. They're asking us to actually divide the second polynomial by the first polynomial. So the second polynomial has to be considered as dividend. If you write p of x upon g of x, this is said to be dividing dividing p of x by g of x. This is called dividing p of x by g of x. Here, the comma separates the two given polynomials. You have to divide the second polynomial, which is p of x, by the first polynomial, which is g of x. second polynomial becomes your dividend and the first polynomial becomes your divisor in all the given questions. And what do you have to check? You have to check whether the first polynomial is a factor of second polynomial. When can p of x be a factor of, when can g of x be a factor of p of x? So g of x is a factor of p of x if your r of x is equals to 0. So if after division you get r of x is equals to 0, you can easily write that g of x is a factor of p of x, or p of x divides g of x completely. Now let's do the actual division and see whether we get which ones we get factor and which we don't. Again, p of x is written inside, which is 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12, and g of x is written outside, t square minus 3. Following the same procedure, your first term, 2t to the power 4 is divided by the first term, t square, and you get 2t square. So 2t square. 2t square is multiplied with this g of x, so you get 2t to the power 4 minus 6t square. So minus 6t square, it will be under t square term. Like terms has to be written properly. Subtraction will invert the second signs. Let me just rearrange this. 2t to the power 4 minus 6t square. Subtraction, sign change, and you'll end up with these terms getting cancelled. 3t cube minus 2t square plus 6t square is plus 4t square. Pay proper attention to signs, addition and subtraction over here. Now the first term is again divided by the first term. 3t cube upon t square. You're left with 3t. Place this 3t over here, and 3t is to be multiplied by your g of x. So 3t cube, this 3t minus 3 is 90, minus 90, minus 90. Subtracting, signs get inverted. These terms, both the terms get cancelled because minus 90 plus 3t cube minus 3t cube. We're left with 4t square minus 12. Dividing 4t square with t square. Since variables got cancelled out and you're left with the number or the power of numerator and denominator is same, next step will give you remainder directly. 4 has to be written over here, multiplied by g of x, you get 4t square minus 4 into 3 is 12, subtraction minus plus, and both the terms got cancelled. You're left with 0 at the remainder. Now, if you get a 0 at the remainder or r of x is 0, definitely you can say that g of x is a factor of p of x. So, since r of x is equals to 0, therefore, g of x is a factor of p of x. Let's check for the next question. In the next part, also, you have to repeat the same procedure. First, we will see whether they are arranged in the decrementing order. Yes, they are. So let's just directly divide them. P of x. Your P of x is to be written over here. And your G of x over here. Now, the first term is to be divided by the first. 3x to the power 4 divided by x square is equals to 3x square. 3x square over here You'll multiply it by g of x. You get 3x to the power 4 plus 9x cubed plus 3x square minus, changing the signs, cancelling the first term out. Here you have 5x cubed minus 9x cubed, which is minus 4x cubed, minus 7x square minus 3x square, which is minus 10x square. The rest of the terms as it is. Minus 4x cubed, the first term, divided by x square will give you minus 4x. Minus 4x. Minus 4x cubed minus 12x square minus 4x. Subtracting, changing the signs. First term got cancelled. Minus 10x square plus 12x square. So this is 2x square. Plus 2x plus 4x plus 6x plus 2. Never forget a term. Now, first term 2x square divided by the first term x square. Got cancelled, you got a constant. So next term is your remainder. So dividing this 2 with this, you get 2x square, multiplying 2 with this, g of x, plus 6x square plus 6x, 2 into 1 is plus 2. Subtraction, change the signs. As you can see, all the terms get cancelled. You're left with 0 as the remainder. So your remainder and quotient are obtained at this level, and you find that your remainder is 0, which means the given g of x, it will be a factor, is a factor of p of x. Since r of x is equals to 0. Next, the third question. The values are arranged in the decrementing order. In g of x, after x cube, you do not have an x square term, but it is irrelevant. You need not place a 0 x square over here. However, in p of x, all the terms should be mentioned and they should be in the decrementing order. Here, as you can see, x to the power 4 term is missing. So you can mention that. X to the power 5 plus 0x to the power 4 minus 4x cubed plus x square plus 3x plus 1. So p of x is written here, x to the power 5 plus 0x to the power 4 minus 4x cubed plus x square plus 3x plus 1. And g of x over here, x cubed minus 3x plus 1. Dividing the first term, x to the power 5 by x cubed. You'll get x square. Place x square over here. Multiply the whole g of x by x square. We'll get x to the power 5 placed under x to the power 5 minus 3x cubed minus 3x cubed plus x square plus x square. Subtraction, changing the signs, cancelling of the first term, 0x to the power 4. It's your first term, so you need not write it over here. Because even if you write it, you'll have to exclude it. Minus 4x cubed plus 3x cubed. So which is minus x cubed plus x square minus x square. So these terms will get cancelled and you're left with plus 3x plus 1. First term minus x cubed divided by first term x cubed. This is a constant. Next step is your remainder, minus 1. Minus 1 to be multiplied by the whole g of x, which is minus x cubed minus plus 3x minus plus minus 1. Subtracting, we'll change the signs. First term gets cancelled, second gets cancelled, third term plus 1 plus 1. So it is plus 2. Here, as you can observe, the remainder is not equals to 0. So the given g of x is not a factor of p of x. Since r of x is equals to 2, which is not equals to 0, therefore g of x is not the factor of p of x. Hope this is clear. In the next question, we have obtain all other zeros of 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. If two of the zeros are root of 5 by 3 and root of minus 5 by 3. Two zeros are given. The variable used is x. So if zeros are given, your x value is equals to either 5 by 3 or x value is equals to minus root 5 by 3. Now, p of x is given to you and you have to obtain all the zeros. If you observe p of x, your maximum power is 4. That means x holds 4 values. And p of x is biquadratic in nature. Biquadratic means having a power 4. Now, you have to find all the factors. So if p of x is a polynomial, is a biquadratic polynomial, then it should have some factors like x minus a, x minus b, x minus c, and x minus g. Now, sometimes this ABCD, yeah, here ABCD are zeros. A, B, C, D are zeros. According to the textbook notations, you use alpha, beta, gamma, or say delta as your zero notations. So the same ABCD can also be written as alpha, beta, gamma, and delta. So this is x minus alpha, x minus beta, x minus gamma, and x minus delta. Okay, two of these are given to you. So let's say this is alpha and this is beta. So x minus root of 5 by 3, x minus of minus root 5 by 3, and x minus gamma, x minus delta. Here you have x minus root of 5 by 3 into x plus root of 5 by 3, x minus gamma, x minus delta. Multiplying this, if you can observe, it is a minus b into a plus b. So it should have a square minus b square, x square minus root of this means 5 by 3. You know that root of something multiplied by root of the same value will give you 2 because it is root 2 whole square. Multiplying root value twice, root means square root twice, you'll get the value inside the square without the root. X minus gamma, x minus delta. Now if you multiply 3 over here, cross multiplication, you get 3x square minus 5 into 1 by 3 into x minus delta into x minus gamma into x minus delta. What are you supposed to calculate? This p of x is given to you. Obtain all the other zeros of this particular expression if two zeros are given. Two zeros are known to you and you merged them together to form a quadratic polynomial. You have to find rest of the zeros, means you have to find the values of delta and gamma. We know that if you have two linear expressions like these, they will form a quadratic polynomial. And here you have p of x given to you, 3x square minus 5 obtained by calculation of the given values. This is in multiplication with the required quadratic polynomial. So you can take this on the left hand side, the multiplication gets converted into division. So you have 3x square minus 5 taken in the denominator. So your p of x divided by 3x square minus 5 is equals to x minus gamma, x minus delta into 1 by 3. This 1 by 3 has no role to play in it. You can easily get the values of gamma and delta by even if you avoid 1 by 3. Now, p of x is given to you. So all you have to do is divide your p of x with this particular value. So p of x and this value becomes your g of x. And whatever you get will be your q of x. So you'll get the result after dividing as q of x, which would be multiplication of the required zeros, expression of zeros. So let's divide it manually. Your p of x is written over here. Given p of x is 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. 4, 3, 2, 1, 0. All powers are mentioned, all terms are mentioned. 3x squared minus 5. Dividing 3x to the power 4 divided by 3x squared. 3 got cancelled. Here you have square, which is x squared. X squared over here, which is 3x to the power 4. X squared multiplied by minus 5. So you have minus 5x squared. Subtraction, terms sign gets inverted. You're left with 6x cubed minus 2x squared plus 5x squared is plus 3x squared minus 10x minus 5. Again, first term 6x cubed divided by 3x squared, which is 2. You're left with 2x plus 2x. 2x multiplied with g of x, 6x cubed. 2x multiplied with minus 5, you have minus 10x. Subtraction, signs got inverted. These two terms get cancelled. You're left with 3x squared minus 5. Again, first term 3x squared divided by first term 3x squared. You're left with 1. Next step is your remainder plus 1. And 1 multiplied by this is 3x squared minus 5. Subtraction, sign change, cancellation, remainder 0. So as you can see, you'll always get a remainder 0 in such questions because you know that these are factors. You'll only get factors if your remainder is 0. It's given in the question that g of x, whatever you have over here, will be a factor of the given polynomial. So what do we have here now? Your g of x, sorry, this is your quotient. Your q of x is equals to x squared plus 2x plus 1. Square means it's a quadratic polynomial. It has 2 roots or 2 zeros. By middle term splitting method or by basic observation, it is x plus 1 whole square. Even if you solve it by middle term splitting method, we'll end up with x plus 1 into x plus 1. So your first value, gamma, is equals to minus 1 and delta is equals to minus 1. How? What you've done is you can either equate these two with 0 or you can compare these two values. X minus delta with x plus 1. Delta is equals to minus 1. And the next value, x plus 1 with x minus delta, gamma value is minus 1 and delta value is also minus 1. Therefore, the other roots are minus 1 and minus 1. Next question. Now, this was the third question. I will do the fourth question. Fourth question states, on dividing this particular polynomial by a polynomial g of x. So you're dividing this polynomial by g of x, so the given polynomial is p of x. The quotient and remainder are this respectively. So quotient and remainder both are given to you. Q of x is given to you, R of x is given to you. You have to find g of x. G of x is equals to question mark. Now, we know that dividend is equals to divisor. This is a formula into quotient plus remainder. So your dividend value is p of x. Divisor is g of x, which you have to calculate, into quotient q of x plus remainder r of x. If you place these values here, you have x cube minus 3x square plus x plus 2 is equals to g of x into q of x is x minus 2 plus r of x is minus 2x plus 4. This complete r of x can be taken over here on the left hand side, because on the right hand side you have two terms. One is g of x into x minus 2 and second is this term minus 2x plus 4. So you're taking the second term on the left hand side. We have x cube minus 3x square plus x plus 2 minus 2x becomes plus 2x and plus 4 becomes minus 4 is equals to x minus 2 into g of x. X cube as it is minus 3x square plus x plus 2x. So plus 3x plus 2 minus 4 minus 2. Next, what you'll do? You will take this x minus 2 on the left hand side. Why? Because you need to get the value of g of x. Here you have multiplication, so x minus 2 will be converted into division on the left hand side. X cube minus 3x square plus 3x minus 2 divided by x minus 2. You divide this, you'll get g of x by basic division. P of x written inside P of x is x cube minus 3x square plus 3x minus 2. This is what we obtained with the last equation, last page. And you're dividing it by x minus 2. So, first term by first term by a basic method, x cubed upon x, which is x square here as it is, x square multiplied by this, you have x cubed minus 2x square. Subtracting minus x square plus 3x minus 2 minus x square divided by x, you'll get minus x minus x multiplied by this minus x square plus 2x. Subtracting again, signs change. You have 3x minus 2x, which is x minus 2, plus 1 and x minus 2 minus change of signs, cancellation of terms, remainder is 0. So we know that if you have your remainder 0, this is your remainder, this is your quotient. So if you have your remainder, this is a factor. Also, it was proven that if you divide these two terms, you will get the value of g of x. So this is the required quotient, or this is the required g of x. Required g of x is equals to x square minus x plus 1. Next question. Now in this question, what are you given? You have to provide with examples. Certain conditions are given to you and you have to provide with examples. So give examples of these polynomials which satisfy the division algorithm and these conditions. So let's consider the first part. First part mein, these polynomials should satisfy two things. First, the division algorithm, and second, the condition that degree of p of x should be equal to degree of g of x. Let us consider this degree as a certain value. Let us consider that we are, for our own sake, we are considering the degree as 2. So here you should have some x square term. Here you should have some x square term. And let's see, what do you get? Can you divide it? Can you get up to an example? So you can have something like this, x minus 2. Here you can write something like 2x plus 1 or 2x plus x plus 1. Let's divide it and get the quotients and remainder. 2x square plus x plus 1, x square minus 2. All you need is degree of p of x should be equal to degree of g of x. P of x is your dividend and g of x is your divisor. Both the degrees are same means the maximum powers are same. You divide this, you will get 2x square divided by x square. This is a random example. 2. So you get 2x square minus 4. Subtracted x plus 5. So in this particular problem, p of x is equals to 2x square plus x plus 1. G of x is equals to x square minus 2. The powers of both are same. Q of x is equals to 2 and R of x is equals to x minus x plus 5. This is what you have to calculate. You have to give examples for certain conditions. And if you want to check, you can check for your remainder theorem. Dividend is equals to divisor into quotient plus remainder. It's called dividend. It's called remainder theorem. Next question. The second part says that your degree of q of x should be equal to degree of r of x. What do you want? In your division, your g of x is over here and your r of x is over here. You have to, your q of x is here and your p of x is here. It's given that degree of q of x, which is quotient, your quotient's degree and your remainder's degree should be same. These four degrees should be same. How can you attain such a result? So let's decide upon what do we want. Let's decide upon a degree that we want. Let's consider them 1. Let's say this is the condition. Your degree of q of x should be equal to degree of r of x. And you're considering this value as 1. So now we know that p of x is equals to g of x into q of x plus r of x. Now r of x degree will always be less than equals to your g of x. But the degree of p of x depends on this term and this term. And by default, we know that the degree of p of x will come from multiplication of degrees of g of x and q of x. If you have x to the power 5 over here, 4 over here, this might have something like x square into x square. And it doesn't matter what r of x has, because either it will have x square term or it will have x term. But mostly it will have x term or a constant. So the degree of this particular p of x, the maximum power depends on this degree of this one, which is the multiplication of degree of g of x and q of x. So this can also be written in the form of formula that degree of p of x is equals to degree of g of x multiplied by degree of q of x. Now we know that we have considered degree of q of x as 1. So if this is 1, you will have to consider some degree for p of x as well. Let degree of q of x is equals to 1, which will be equal to degree of r of x. And let's consider q of x as well. P of x as well. Let degree of p of x. Of course, degree of p of x will be either 1 or greater than 1. So let this degree be equal to 3. So we know that by understanding, if you want to take a bigger problem, you can take 3, else you can take 1 or 2. If you take 1, your g of x has to be a constant. because its degree has to be 0. Okay, let's reduce it to 2. So we know that degree of these is, oh, I wrote multiplication, it's supposed to be addition, sorry. Yeah, because the powers get added. If 4 is equal to 2 plus 2, 4. Powers get added, terms get multiplied. So degree of p of x is 2. And degree of p of x agreed to here. And this q of x degree is 1. Then definitely g of x degree has to be 1. In order to 2 is equal to 1 plus 1. Therefore, degree of g of x has to be 1. Now let's assume certain values of p of x and g of x. Let p of x is equals to x squared plus 2x plus 1. And g of x is equals to x minus 1. So x squared plus 2x plus 1, and this is x minus 1. X squared divided by x is equals to x. So here you have x, this is x squared minus x, subtraction, sign change. So you have 2x plus 1. 2x plus 1 is 3x plus 1. Here, if you keep on dividing it, 3x divided by x, you're getting 3 plus 3. 3 into x is 3x minus 3. You change the signs, you're getting it cancelled. So you are getting q as 1, degree as 1, but you're not getting remainder as 4. Okay? Because we considered the power as 2. Let's consider another value. Instead of x, instead of this, you can consider the power to be a cube value. What happens if you take the power as cube? If you take the power as cube, by default, you will have to take this as 2 or a square value. Okay? Because you have considered the power of your quotient to be 1. So degree of quotient plus degree of divisor should give you degree of your dividend. Let's calculate the value of quotient and remainder and see whether we are getting powers as 1 or not. First value, x cubed divided by x squared, you'll get x multiplied by this, x cubed minus x, subtraction, 3x plus 1. Now, 3x divided by x squared. Observe, here this is not possible because degree of numerator is smaller than degree of denominator. That means this is your remainder by default. What would have happened if we took another example? Say x cubed minus x squared plus 2x plus 1. You're adding an x squared over here. And here you're taking x squared plus x plus 1. You're taking a bigger example. Then x cubed minus plus x, we get plus x squared plus x. Subtraction, minus 2x squared plus x plus 1. This one divided by this, you get minus 2. Minus 2x squared minus 2x minus 2. Subtraction, sign change, at 3x plus 3. It cannot be further divided because this power is x and this is x squared. Now there's a possibility that while cancellation of this, if you change the coefficients, your second term might also get cancelled at certain values of these p of x. Okay, so you might end up with a remainder without this x term, in which case your condition gets your condition is not satisfied yet, that the degree of your q of x, which should be equal to degree of r of x. In which case you'll have to change your values, change these coefficients, or change the degree. By trial and error, by hit and trial method, you'll be able to come up with certain examples. You just have to use your logic and basic formulas. So these are the two examples for when degree of q of x is equal to degree of r of x. We have considered both as one. The next condition is degree of r of x is equal to 0. Degree of r of x is equal to 0, that means you should get a constant in the remainder. So let's consider an example. You need degree of r of x is equal to 0. Now, degree of r of x 0 does not mean the value of r of x is 0, but you can consider r of x as 0. If r of x is equal to 0, 0 is a constant, which means your degree is by default 0. But let's say we need a numerical value. So what you'll do, you'll first, a short method is take a complete whole square. So you have, say, x squared plus 4x plus 4. You know that this is x plus 2 whole square. So x plus 2 into x plus 2. Now change this value of 4 by any other value. So let p of x is equals to x squared plus 4x plus 5. Now this works most of the time. Let's see if it does. And you're keeping g of x as it is, x plus 2. X squared plus 4x plus 5. So now I'm directly writing it. You can go step by step. You can do the calculation of division in your mind as well if you've practiced it a lot. As you can see, here you ended up with 1. Okay. Here, degree of r of x is equal to 0. So all you had to do is take any perfect square or take any factors, any polynomial where r of x is equal to 0, and then change the constant by 1 or 2 digits. Do not change any other coefficients or any other values. Just change the constant of your p of x by a few values, and your degree instead of your remainder instead of 1, you'll get instead of 0, you'll get a 1 or any other numerical value there, which is a constant, and any constant has degree 0. So that ends your exercise 2.3 of polynomials. Thank you for watching. We'll continue the next optional exercise 2.4 in the next class. Good day.